Okay, next stage is getting that put on that. The first thing I've got to do, I've disconnected the motor, and you see I've turned it that way. So this is the plan. When I laid it out this way, I want the belt towards the chimney. I can see two issues here. Number one, when I tested which direction this motor is going, I find it spins this direction. A compressor, there's a plain arrow on it that it's got to rotate. Let's give it a close up. There's the arrow. It's got to rotate that way. So that is the counterclockwise, which means that is going, if I remember right, it was spinning this way. So we have to have it spinning this way. Now, with these type of motors, to get your direction of the motor spinning, all you have to do is change the start winding inside here. That's what I got to do with the motor, is to change the start winding, the wires. Also, when I look here, my gauge is going to be in the road here. So I'm going to swap these two things around. Well, our pressure sensor for our pressure switch that turns it off, we got to change that as well. So a lot of people don't know about line wrenches, but line wrenches are much better than your there. So I've already disconnected it from there, and I see I cannot get a line wrench on there. Not enough room for that. So this is plastic, so we could leave that on, which I think is what I'll do. And we gotta, okay, right. We gotta disconnect things inside here, and thinking my best route out. I think that would be the best route out, because as we got to spin that way and taking it out, cables go in first, so we're ahead of the game to disconnect all the wires in there. Okay, so now I've already disconnected the power from where I was getting the source from. So we don't want to drop this screw. Keep the screw with the cover. Put that in my toolbox so it don't get lost. And have a look what we got disconnect here. And I need a light here, so I'm going to figure that out. I'm going back to my plans. I've got one or two methods. I've already measured the base of that compressor out. And I found when it's 7 inches here, for that to mount that, we only have 6 inches here. So what I got to do is got to add a plate on here, going that way, as well as this way, and that way. So that'll be the fabrication end. You know, you won't be able to see what I got to do there anyway, so I just explained it. I'm not going to bother with the winding today. When I come to do the winding, I'll show you how to reverse the start winding, and how you can figure out which are the two wires for your start winding. Because remember, the motor also works with your magnetic field. So when you apply it, then the current goes through the start winding, it will give the direction of the rotor to spin, whether it's that way or whether it's that way. Your magnetic field plays effect there. Okay, Well, I dug my little special tester out here. I built this way back in the 60s. And just to explain quickly how the system works. You see one light, that bulb is lit up right now. And you see on this side I got a red one. Also got a coil. Now these two are joined together. So therefore, it's actually at a reduced current rating. A slight voltage as well. The idea is, I gotta put the camera down here. Okay, well, I just snapped the alligator clip off my neutral one. Let's see if I can't get this in so you can see how this works. Try that. Okay, when I was working Moore Electric, that's where I came up with this. Bud Moore gave me the diagram, and when I was in vocational school, they loved it, and they made me draw the diagram out for them when I was in my appliance class. But the idea is you can join the two wires together, so that's basically what you'd call a dead short. And as you can see, the red light came on solid and the heating element heats up. Now the whole purpose, and this is perfect, and why I built it, when you're doing a motor like this will go heavier on the start winding to make sure your centrifugal switch inside that motor is working. Once it cuts out, then these two bulbs will balance together, and you can set and line the motor up as well at the same time. That is how that tester works. For me to use it on this motor, we're going to have to fix my leads. Okay, well, put some new alligator clips on here so it can assist me. Anyways, go ahead and knock the end plate off here. Get this out of the way. If you were taking the motor completely apart, you just put some little scratches on here as to which way they came off. The last one. Now, put the ratchet down, we'll get a, I don't know what you call these things, but I call it, that's how to make a nut driver. These things here, for those of you who don't know, they are capacitors underneath, and what they do, they work in junction with the start winding. So it gives you, instead of this kind of a torque, you got more of a torque like that. Good example. On your steering wheel, in the old days we were taught 10 o'clock and 2 o'clock positions with our hands. And you go to the racetrack, the first thing they teach you is 10 o'clock and 2 o'clock to 3 o'clock and 9 o'clock. Well, that's basically what these things do. Okay, now let's knock the plate off, and sometimes that can be a little fun. I have a tool, if I can remember where I put it. Slowly I'm getting around to trying to get this back in shape, and I'm going through my stuff and downsizing at the same time. Just getting to that point, as well as to that age that it's time to start thinning down. Well, this'll work. Gotta find a spot here to split it from there. Broke free, that's what we're after. So that's what the inside. This is the centrifugal switch that I was talking about. This is your overload. And what it does, after, if I remember right, it's 1025 RPM. This is part of the centrifugal switch. It throws in like that, causing that to open the switch here, shutting the start winding off. So now we gotta break down to find out which is our start windings. As you can see, we got 4 wires here. 2 of them are your run winding, and 2 of them are your start winding. So now we'll go get the multimeter, and there you have it. That's your start winding there, and that's the thick wire is the run winding there. So you see, that's why being thinner is why the start winding has to come off, or else your motor would burn up. And I've done lots of motors. That's working perfect yet. This is just time here. Could lose a little lubrication on the bearings. Still good shape though, but we'll lube them up a bit at the same time here. Anyhow, let's get my multimeter and figure out our run winding is a lot less resistant than our start winding. So we put it onto the ohm scale, which is your horseshoe, and start tracing the wires out. Okay, that's 1, that's 2, 2. Oh, I see. It was catching here. Disconnect that. And wrapped up like a pretzel here. Twist these wires a bit so they're easier to trace. Everything in the road always. Okay, that's a little easier to change. Trace, I should say. Okay, that appears like that is a run winding. And so that goes to the capacitor, and capacitor goes there. So yeah, that's run winding. Okay, so that one's run. Okay, so now this one. Ooh, that's a good clue. Good thing we're checking this and having to do this. Okay, this appears to be the wire going into the capacitor. Yes, so it's that one. And which one would I say? That one's run. Going to the capacitor and down to here, down to here, down to here. So these 2 should be our start winding. Confirm that. .5 run. 3.4. So it looks like these 2 should be our no reading there. So that's terminal 1. And 0.1. Okay, those 2 are our run winding. So it's these 2 are our start winding. Start winding is always the higher resistance. Okay, let's turn my meter off and that one goes now, goes there, and this one goes there. Okay, I'm just gonna pop this on, make sure we're correct. That's another advantage about my little tester there. We don't need to tighten them. If I got the right two, the snout should be the opposite direction. I'm going to pop a couple in to verify before putting all together. Come on, where's that hole? Okay, let's try this one. Oh, there we are. Okay, my 2 leads here, right there. So this is our return. Now, as you just heard, because I got loose, I gotta tighten a bit. Okay, not a problem. This is the fun part always. You don't knock the two plates off, trying to find the hole in this other end. Feels like it's there, but it's not. Well, we know that one's in. Well, where's that hole? Oh, see. A bit of a challenge here. I felt like it's there, but it's not. Well, I didn't want to, but it looks like I'm going to have to. See if I can't balance this somehow. Okay, right, got this one bolt here tightened. I wish you could get your finger in there to... Now can I see where we're at? The hole's right there. It should be right there. Now, I'm going to turn the camera off while I figure this alignment out. Okay. Well, I don't remember where I left off on filming it, so to bring you up to date on there, if you remember right, I did say you had to switch the two wires for the start winding to reverse them, which direction this motor spins. Well, this is why I didn't bother filming it until I got to this point, because I knew this was going to be very time consuming. I'll explain as to why this was so time consuming. First of all, it said switch the wires. Well, I just automatically switched to, tested it out, still ran the same direction. And I got thinking, well, that doesn't sound right. So I sat down and I drew me a diagram, a schematic, as to how this was. And what we have here what has been done here was basically this top section here, the one in blue, is they joined right here, both windings together as one terminal. And there it is, right there. I don't know if you can see it. So I had to open this up in order to, then took my multimeter, and that's how I found out that this was common, because I took all the wires off and took my multimeter off. Now your start winding is a higher resistance to your run winding. Furthermore, second identification to your start winding is your start winding is always the thinner wire. So that is your start winding right there. So what has to be done here now to reverse the direction of this rotating, so that we get it rotating the opposite directions, we have to take this wire and this wire, switch them around. So I got to make extension piece onto here, and now bring that to the common, because this is the common for both windings, as you saw in the diagram here. Then I have to make another wire from here to come to our capacitor here, and this should then spin the other direction. Now, when I finally got to my the common direction, this is the wire. As you see, it's a thin wire, and I just showed you on the multimeter confirming the start winding. When you got to add a wire onto it now, it's important you clean the shellac off of this winding. These are all coated with shellac, so you got to clean the shellac off the end here. And now we're ready to add a wire here, because there's no way you're going to be able to put that wire over here to the capacitor. That's why we have to add a section. So I would like to solder the things in, but I'm trying to find a tip for my soldering gun. So I'm going to be hunting for that. I want to solder these together, and I'll get back to you after I get that done. Well, I came up with one of my expensive mini straps. So I put one here for these three to stay in place. I'm going to put a second one in here using some of the existing string and part of the winding, because I can't get fingers in there. You don't want any wires flopping around there when it's running that can catch. So there we have that. That's as close as you can get to what originally was there. I'd like to get one more in there if I can. Let's get my poker here and see if there's enough clearance. Oh, that one won't do any good anyway. That's what I cut open to get this common terminal. Okay, we'll snip those off, and we'll have to put this wire underneath the centrifugal switch here. Right, I put them away. Figures. Okay, let's get our end cap here, and we gotta get this wire under that centrifugal switch. We'll just take this one screw off, get it under here, like so. Screw it back in. Make sure there's no get a couple of bolts here, and you'll see the advantage of my tester here in a few minutes. Oh, this is for 5/16, right? Found my 5/16 nut driver. Missed. You can see why I missed. Not in line yet. Marks there, yeah. So theoretically, it should now be running in the counterclockwise direction instead of clockwise. I'm just going to put 2 in for now for the test. Now, let's see. I'm going to get this set up so that you can see the action of my special tester here. Turn the camera a little bit this way. Let's have a look here. Show the bulbs. Okay, yeah. Oh, rats. Well, I did. A clip came off the neutral wires. I knew there was something else I needed to solder. While I was at it, let's see what happens here. Now you see how the red bulb is and the heater coil open, and that's the direction we want. That's the advantage of a reduced voltage. This takes the current. So now it's just a matter of finalizing, setting it up, and that's a bit of a trick. You just keep tightening with the 4 bolts until you line everything up, and that spins and runs on that before plugging full voltage to it. So that's how you can reverse a motor if you ever have to reverse one. Well, while I'm at it, next step will be mounted onto the tank. I had one belt, and I discovered this belt is too short. It won't even go around the flywheel here, so I'm going to have to calculate as to what belt size I need when it comes to that. Just thought about it. I've got to basically adjust it so to show you full extent of how this works. I'm going to let you see this run and see if you can identify the new problem. We have a new problem with it. As you can see, it's going the right direction now that I need to match that. Now you see the red bulb? It's a full brilliance. You see my heater coil is heating up, and I see I need a new coil on it. Remember, it's a reduced voltage to the motor itself, so it takes longer to get going. This is where the weakness of that coil is coming in. Now you hear it starting to speed up. There we have it. You see how that works now? Fully running. So, what I thought to be a problem isn't a problem. You just gotta have to adjust the tightness, like I explained about setting of the bearing. That is what we're at. I just saved me about $300 and some odd in buying a new motor by doing that. So with that, we're going to conclude this motor section of just getting this compressor all up and running again. So say thanks for watching. We'll let you hear the centrifugal switch. You heard the switch just close in now. So that's working 100%. Thanks for watching. Don't forget to like, subscribe, and do, by all means, comment. I'll just add a feature here. What I just showed you here was all part of my training back in there. If you watched my biography, which I call My Story, part 1, I got it in 4 parts. Part 1 is my early stages, from birth to when I first started the career training. Part 2 is my early years. Part 3 is my mid-years. And Part 4 is my later years to present. So if you haven't checked them out, do go check them out. Thanks for watching. And don't forget to subscribe, like, comment, do comment. And remember, I still have stickers available. They're $5 each. And we'll say adios.